All right, the point of this exercise here is what we're doing is we're going to sketch the perpendicular bisectors of the three sides of a triangle, and then we're going to make some observations about what we see. So we're going to draw three triangles. We're going to sketch the perpendicular bisectors of each of those sides. We're going to write the equations for those perpendicular bisectors, and then I want you to make two observations. I'll give you a couple of kind of cues for what sorts of observations we're going to make. Okay. So first, let's go ahead and sketch in our horizontal and vertical axes here. Let's see, I want to make sure plenty of room. All right, so basically we're just going to plot points A, B, and C. There's A. Okay, and let's see, there's B. Up top is C. We're going to connect A, B, and C, form a triangle. You want to make sure that you are as accurate as possible with this. If you're drawing a sloppy, it's going to make things more difficult for you. Because we have to find the midpoint, and the midpoint is on a lattice point, but if you draw a sloppy line, you're not going to notice it. All right? So you can see I just pointed at the midpoint. There's the midpoint. All right, and of course on the other side, our perpendicular bisector will cross through at that midpoint and have a slope that is the negative reciprocal. All right, so you kind of eyeball that. Remember the negative reciprocal. Look that up if you don't remember. I'm playing around with the camera here a little bit. You want to plot as many points as you can before you draw your line. That makes sure that your line is, again, as accurate as possible. If you place the ruler too close to 2 points, and as you get further out, little errors get compounded larger. To write the equation for that line, you just need to find its y-intercept. So it's important that you mark accurately where that y-intercept is, and you can kind of figure it out. Okay. And here, when I draw the second line, notice I'm only going down to the y-axis. That's so that I can find where the y-intercept is. I don't need any more than that. So I've got my two perpendicular bisectors. The third one is easy because it's just a vertical line. X equals 7. And we're done. Although I'm going to come back later and mark what that point is where they all crossed each other. All right, so here's our second triangle, DEF. So we're going to connect it. We're going to make our three segments. Find your midpoint. Plot some points that you can draw in your perpendicular bisector. Remember, it has a slope that is a negative reciprocal of the segment of the slope of the segment it's crossing. The second perpendicular bisector is just a vertical line, so easy. Third one's a little bit trickier because the slope of the perpendicular bisector is negative 3 over 2. So you want to draw enough points that you can reach down to where the y-axis is. By the way, when you're writing these equations, I want all of your y-intercepts and slopes to be as fractions. No decimals, no mixed numbers, improper fractions. All right, so now we have our third triangle. It's a right triangle. Notice the first triangle was an acute triangle. The second triangle was a obtuse triangle. The third triangle is a right triangle. The first two perpendicular bisectors on the right triangle are easy because they're just horizontal and vertical lines. The third one has a slope of 1/2. You notice the y-intercept is negative 3. And now I should go ahead and we've labeled all three points of intersection. We're labeling them as acute, obtuse, and right. All right, now here are the two observations I want you to make. 1, do you notice anything about the way that the three perpendicular bisectors cross each other that doesn't at first just seem obvious that that would happen? Is there something about the way these three lines intersect with each other that just seems like a bit of a surprise? All right, or just describe how they intersect with each other. Second, do you see any difference between the way they intersect in the acute, the obtuse, and the right triangle? And it may not be obvious at first, but once you graph your own, you should see that there's a pattern in the way that they meet in an obtuse triangle, there's a pattern in the way they meet in a right triangle, and there's a pattern in the way they meet in an acute triangle. And I'll give you a hint. The words on, inside, and outside are key. Right? So go ahead and do the second one on your own, and then write up your observations on the back of the second sheet. Good luck.